welcome to our climate change discussion. We're the Climate Change Brothers. We talk about agriculture, engineering, and energy. So today we have a great topic. It's on life cycle analysis.
Life cycle assessment. Well, they're both kind of the same.
Yeah, well, you try to correct me, splitting hairs.
I'm always
here,
correcting
so,
you, yeah.
Of course, the brothers do. Okay.
Yeah.
So, you know, when people talk about, renewable energies are so much better than, the non-renewables and stuff, well, you have to consider everything. And that's what life cycle assessment is supposed to do, right? Is consider the whole lifetime of the energy production of things, or whatever the energy costs for any product, right? That's called a life cycle assessment or analysis, right?
Yeah, it can involve a number of different things. It's usually for different products, but we can talk about energy or different processes itself. It can apply to
any product that someone puts out.
Yeah,
can have a life cycle assessment. A car, a pair of shoes, whatever, right? This all has a life cycle assessment on how much that costs the environment to produce, right?
Yeah, the environmental impacts, and we'll talk about that later. But yeah, exactly.
Okay. Well, mainly when we're talking about climate change, a life cycle assessment can talk about the greenhouse gases it produce over its lifetime, right? So that's something that as far as climate change is concerned, what people are a lot talk about, right?
Yeah, that's kind of where most of the emphasis is, but is like there's a lot of environmental impacts that have to do with pollution. You have water and land and soil that can be affected. So it's not just greenhouse gases, but that's where the emphasis seems to be placed.
Right. Most people talk about the greenhouse gas problem.
Yeah.
Okay. But there's a lot of other problems to the environment for certain products, even though they may not produce as much greenhouse gases. So there's that to consider, right? So what's the definition of life cycle analysis? What would you actually, if you had to sum it up, what would you say?
Find the sum it up. Well, I'll just give you the definition of what it is. It's the systematic analysis of the potential environmental or other impacts associated with their products throughout all of their life cycle stages of procurement, production, use, and end of life. Well, there's two things you kind of want to concentrate on there. There's the stages that go through, like procurement, production.
There's 4 stages. Since they kind of group it into that, but there's more. But
there can be more, but those are the usual ones. So, like the example I give is if you are making a cotton shirt, the procurement stage would be where you grow that cotton, and then you have to harvest that cotton and then transport it to a textile factory, and that's where the production stage comes in. Right. Use all these chemicals and different things, water and all that, to make and machines to make your shirt from the textiles. Okay. And then, so that's the production. Then there's the use stage where you're wearing the shirts. And then after that's the end of life, where you either dispose of it in a landfill, or you can recycle it by, turn it into a different product, or you can reuse it, give it to somebody else. So there's those are different possibilities for the end of life stage.
So the four to sum up, the 4 are basically like procurement or production, processing, usage, and then decommissioning. Something like that, or end of life, you want to call it.
It's something like that. That could work.
They're all different terms, but those 4 are kind of like that. They all come with a cost for the environment, though, in terms of CO2 production or greenhouse gases, right?
Well, we'll talk about with silicon chip manufacturing. You use these acids to produce the silicon chips,
right?
And those acids give off gases, even though they're not carbon dioxide. They still count towards greenhouse gas emissions because they're nitrogen or sulfur gases that contribute to global warming. So that's kind of they're even worse than carbon dioxide. So I mean,
so they have a multiplication effect towards what they're doing and producing. Also, if you properly dispose of those chemicals, which not everybody does, especially maybe in third world countries where they might have mining some of these materials, but there's probably a cost to properly disposing of them, which is more energy it takes to do that. So that's also more greenhouse gases that are emitting, in a sense, if you do it properly. So take that into account.
Yeah. Well, an example we kind of give of life cycle assessment is with a cell phone, and we've talked about this before. But with a cell phone, you have all these components that make up the cell phone. Right. You have to secure the raw materials for it, and then make that component. And then all those have to be transported and shipped to the final assembly process of it to make that cell phone. So
and the cell phone's pretty complex. It's got a lot of components, and so there's a lot of sub categories you could do just for those as well, like the camera or the microprocessors or the screen, and all these things then they really assemble all these things together. So each one could also have its own life cycle assessment, and then you add all those up to make a cell phone.
Yeah, exactly.
You had a great project that I think would be good to talk about, and that was looking at one of the agricultural products that be growing out in the United States. Can you want to tell us about that, the Guayule plant?
Yeah, the Guayule plant. So that was something that was part of a bigger organization called the Sustainable Bioeconomy for Arid Regions, and it involved a lot of different universities, not just the U of A, but those and several companies as well, where they wanted to make a couple of plants be part of the bioeconomy. The focus was mainly on Guayule because it's important that we can use it to make vehicle tires. Because in every vehicle tire, you have to have some percentage of natural rubber in it, because the tire is made of synthetic rubber, which is from petroleum, but then you also have to have natural rubber. And our only source right now of natural rubber is in Southeast Asia from the Hevea tree. So you have all these industrialized countries coming up. There's more population. There's going to be more. We're going to have to produce a lot of electric vehicles in the future. We're going to need a lot more tires, so that there's going to be a lot more demand on this natural rubber. So it kind of looks like our other alternative source would be this Guayule plant, which it's indigenous to like the desert climate, the Chihuahuan Desert specifically, where in Mexico they grew it there first, and then it kind of migrated to the United States later on. And so the good thing about Guayule is that we've done a lot of studies on it, and we kind of know how to grow it. And so that's kind of what I was involved with, was helping with the irrigation management and computer modeling of it with the Guayule. So it's very good because it can be a sustainable solution. It may not have to take a lot of water. It can survive on lower amounts of water, so it'd be good for it.
You discovered that too when you guys were doing the
studies
with it. How little water it could take. That was one of the studies you did, right? So.
Yeah, exactly. So that's kind of one thing that came out of it. But so we can do a life cycle assessment on Guayule itself. And one thing, there's a couple stages that are part of a life cycle assessment, but one of them we want to talk about was with the life cycle inventory analysis. So kind of just want to go over an example of how we can make a tire out of Guayule. You have to think of all of the stages that go into that, which is the growing the Guayule itself, processing the Guayule in another plant, and then you have to take that process, the rubber that comes out of that, and then place it into tire manufacturing. So when you do that, part of this inventory analysis is taking into account all the inputs and outputs that you have. So your inputs would be like your chemicals, your energy, your water, all those things that you input into making that product. And your outputs would be the final product itself, which is, in case the Guayule tire would be the vehicle tire itself. And the outputs also consist of the waste products, which would be either solid waste or gaseous waste like carbon dioxide, which we place the emphasis on. Solid liquid, and wastewater is it? Yeah, right, wastewater is another one. So for example, with Guayule, we have growing the Guayule, and that consists of using water to irrigate it. We also need fertilizer, and since in our studies we looked at drip irrigation, you have the chemicals you have to use, such as acid and bleach, and you have the irrigation materials, which are mainly plastics that you use for the drip irrigation. You have the fuel that you need for the farm machinery to to harvest the Guayule and put in the pesticides and all that kind of stuff, and then the energy for pumping the water too. So that's just the inputs you need for growing the Guayule. You then have to take that Guayule to a processing plant where you need more water to process it. You require electricity and propane as far as energy requirements, and then you also have chemicals to extract that rubber, which consists of like hexane and acetone. Then that Guayule rubber goes to a tire manufacturing plant where not only do you have the Guayule rubber, but you have synthetic rubber that you mix it with. You have carbon black, steel, fabric, and other chemicals, and then you also are consider the energy intensity of all this processing for those materials. So that's in a nutshell kind of what when you do the life cycle inventory analysis, what kind of goes into that.
Right. So then there's also the disposal of the tire as well. I mean, at the end of its life, right?
Yeah, there's the disposal, and that's actually a good point you brought up, because You can do a lot with the tires. A lot of times you can recycle that rubber,
Right.
like as crumb rubber, they kind of call it. They tear it up and then they recycle it. You can make playground stuff out of it.
Right.
Different, just a
So
lot
the
of different.
little fake mulch stuff
Yeah.
they do for like on that as well. That's for that. Like
Yeah.
a ground cover.
Yeah, ground cover. There's a lot of there's a lot of different things for that. But you can also make your energy from it. So you can make you can pyrolyze the tires and you can
It's got petroleum products in it.
the pyrolysis can make oil out of it, so you can use it for energy, or you can make tire-derived fuel where you kind of incinerate it. And so there's a lot of different there's a lot of different things you can do with the tire at the end of life. Not
Right,
just
so that's
not just put it in the landfill, but there's other things you can do with it. And that's part of the life cycle assessment you're talking about.
Right. And this is a great project because the more we can grow indigenous in our country, the processing part where you transport things is going to be less as well. Transportation takes up a lot of energy as well. And so the more and more you can process in your proper country, then that saves on shipping. And that's also a greenhouse gas cost as well.
Yeah, and they actually studied the Guayule plant during World War II because a scenario that happened back during that time was that we were cut off from the natural rubber supply in Southeast Asia, so we needed to try to produce our own domestic supply of natural rubber.
Right.
So that was.
No, it's great. I mean, it's a great project all around. I kind of need it, and you can have a USA-made product here. Plus, it's great for the farmers that can now grow a cash crop that's in the desert, which could be a great advantage for them as water starts to be more and more scarce here in Arizona. So it's great.
Exactly. That's good.
That's what I'm talking
Good
about.
point there.
We talked about petroleum products being in it. It'd be nice if we could substitute those petroleum products from maybe stuff like I mentioned carbon black. Could we do that with biofuels maybe instead of using maybe non-renewable petroleum?
Yeah. There's a couple of things like you could do. Your tires a lot of times made out of isoprene, which is kind of like a polymer, the synthetic part of it, and so you can make isoprene from fermentation with certain. I think actually tire companies have tried that before. They made isoprene from microbial biomass, and so you could do that. Carbon black. There's a process right now that they've kind of come up with. It's called the noise process, but it uses carbon dioxide, so you could. One of these climate change things that could help is to recycle that carbon dioxide to make the carbon black, which could be put in the tires. So
a double whammy.
Yeah, so there's a double. So there are things we can do to reduce the petroleum uses that we need for making products such as tires.
You had a little bit of that in your. Talk a little bit about renewable energy. In your book here, a little bit about biofuels manufacturing, right? So, you talked a little bit about the inventory analysis type of life cycle assessment. There's another type too, which is called the impact assessment, right, for life cycle. And what does that mean, impact assessment for a life cycle analysis?
So here, a definition here is that you determine the relevant environmental impact categories and assign the necessary environmental indicators to each category, and then generate the results as functional units from these indicators. So you have two things going on here for a life cycle impact assessment process. You have the impact categories, and then associated with each impact categories are indicators, environmental indicators. So examples I give of this is the environmental impact for the global warming is climate change. And the climate change can have two different kinds of indicators. You can have ozone depletion, which come from certain gas, or you can have just greenhouse gases that are considered global warming potential. So those are two different indicators you can have for when you're assessing climate change. You can also have situations where you're looking at resource depletion. So we're talking about energy and water usage. Those will be the indicators, the energy requirements. You have fossil fuel depletion, and you have critical minerals depletion. So you have all these indicators in that impact category. Another example is with air and water quality. So in land quality, so you have other gases that you can emit that would tend to give off maybe acidification potential or smog, producing smog. So those would be indicators. And, and if the pollutants are toxic to the environment, that would be ecosystem toxicity, would be an indicator of the air and water quality impact category.
Very good.